This video will cover performing joins in dplyr. By the end of this video, you'll know how to perform relational joins in dplyr and how you define relationships when using dplyr join operators. The R code in this video is available on the Learning Management System. You'll use the customers.rds and orders.rds data files. You should download all of those now if you'd like to follow along. In previous videos, we covered using concepts from relational data to perform joins between separate tables to combine information between them. dplyr provides a full set of relational data operators for performing joins. Each one has a name that goes something like a word followed by an underscore and then join. These names are very intuitive. For example, inner underscore join will perform an inner join. Left underscore join performs a left join. Right underscore join will perform a right join, and so on. How do these functions work? Each join function requires two arguments. Each must be a tibble or some other table of data. The first argument is treated as the left table, and the second argument is treated as the right table. So just in this sample code here, I'm performing a full join on left.table and right.table, then saving the resulting output in a variable called join.table. You're generally going to use these join functions with the pipe. Remember what happens with the pipe. It replaces the first argument with whatever is on the left-hand side of the pipe. So in this example here, I have a variable left.table. I'm going to pipe that to full join, providing right.table as the argument. This will join left and right table, using left as the left table and right as the right table. Joining data requires that you define relationships. Unless you specify otherwise, dplyr is going to assume a natural join. What this means is that all variables with matching names between the two tables will be used for relationships. When you do this, R is going to give you an output message listing the relationship variables that it used. That's enough information for us to start performing joins in R. So let's do that. Here I'm going to run some setup code. Since we're joining data, I need two tables of data. I have one in the customers.rds file that I'll store in the customers variable, and a second in the orders.rds file that I'll store in the orders variable. Let's run all of that code. These are new data files, so it's always a good idea to take a look at what we have. I'm going to glimpse the content of each data file. First, we'll start with the customers table, and let's also glimpse the orders table. You can see these tables look very much like data we've used in previous videos. The customers table includes three variables: customer ID, which is an ID number for each customer, the name column, which is the name of each customer, and the planet column, which is the planet each customer is from. In the orders table, you have a product column with the name of a product, a customer ID, which is the customer ID of the person ordering that product, a quantity, and a price variable. Glimpse only shows us the first few values. Let's print out each of these tables to take a look at the full content. They're both very short, so they'll print out in the console window. First, the customers table. It looks exactly like previous examples. We have 4 customers, each with their own customer ID. Looking at the orders table, again, there are several orders. You'll notice the customer ID 14 for Lando Calrissian never shows up in the orders table. And also in the orders table, there is a customer ID 0 that does not show up in the customers table. These will be important when we consider different join types. Let's look at performing a few joins. We'll start with a full join. Remember, a full join keeps observations from both tables, regardless of whether or not the relationship variables match. In this case, you can see the joined table. R has told me, because it's performing a natural join, which variables it used to join on. Here it is just customer ID. That is the only variable name that's common between both tables. If you look at the output, you can see the data have been joined on the customer ID. Because we performed a full join, row number 5 includes Lando Calrissian, who has ordered no products, so all of the product information is NA. Likewise, row number 6 includes the order for product blue milk. Because customer ID 0 does not show up in the customers table, the customer information is NA. We could also perform an inner join. Remember that inner join only keeps observations where the relationship variables occur in both tables. What you can see here is those records with NA values are excluded, the case with Lando Calrissian, who has no orders, and the case of blue milk, the order with a customer ID that doesn't occur in the customers table. A left join will keep observations in the left table, regardless of whether or not they have a match. The left table is the customers table, so here the Lando Calrissian observation is still included. A right join does the reverse. It keeps observations from the right table, regardless of whether or not there's a match. So here the blue milk product observation is included, but the Lando Calrissian observation is not. The anti-join gives you observations from the left table that have no corresponding match in the right table. Here the left table is customers, the right table is orders. You can see that it gives me Lando Calrissian, the customer with no orders. Alternatively, I can perform an anti-join using orders as the left table and customers as the right table. This gives me the blue milk order, the order where the customer ID does not occur in the customers table. It may be that you don't want to perform natural joins. You can explicitly define relationships using the by equals option. There are two ways to use it. The first is you can just provide a vector of variable names with each variable name inside quotation marks. In this example here, I say by and I provide the date and region variable names inside the C function, which creates a vector. In that case, R would form relationships over the date and region variables, regardless of which variable names match between tables. Alternatively, you can define relationships using a vector of variable name pairs. These are pairs of names inside quotation marks, separated by an equal sign. The way R interprets this is it defines relationships using variables on the left-hand side of the equal sign as names from the left table, and pairing them with variable names on the right-hand side of the equal sign from the right table. This is a good thing to use if the variable names you'd like to define relationships over don't match between your data sets. So in this example that I have here, I'm specifying that the variable name with a lowercase d, date, in the left table should match values with the variable name date with a capital D in the right table, and values of the region variable in the left table should match values of the state variable in the right table. Unlike natural joins, if you explicitly define relationships, you may have some overlapping variable names. A variable name that occurs in both the left table and the right table, but is not part of the relationships. When R joins tables with overlapping variable names, it changes the variable names so you know which table they came from. By default, R will add .x to overlapping variable names from the left table and .y to overlapping variable names from the right table. You can change this behavior. If you'd like to control what kind of text is added to overlapping variable names, you can use the suffix equals option. This is going to be a vector of text with two entries. The first entry is added to overlapping names in the left table, and the second is added to overlapping names in the right table. So in this example that I have here, I'm setting the suffix to .left for variable names in the left table and .right for variable names in the right table. If I were to join two tables with overlapping variable names, those variable names would have .left appended if they were on the left table and .right appended if they were from the right table. You can use the empty string, two quotation marks next to each other, to append nothing. But remember, you can't do this for both tables because you need to keep the information separate and the variable names are exactly the same. Let's take a look at this in R. Here I'm going to perform a join, explicitly defining the relationship. You can see I use the by option and I set the relationship variable to be customer ID. This leads to the exact same result as the natural join because remember, customer ID was the only variable name that matched between these two tables. The big change is because I've explicitly defined the relationships, R doesn't tell me what they are as it joins the tables. Let's go back and look at my code. An important use of the by option is to join data when variable names for relationships don't match across tables. So let's work through an example of that. To do that, I'll need to create a table where variable names don't match. So first I'm going to take the customers table and I'm going to rename the customer ID variable to cust.id. I'll save that in a new table, customers.new, and we'll take a look at it to make sure that that change actually happened. Looking in the output window, you can now see that this customers.new table has a cust.id variable where it used to be customer ID. If we try and perform a join using this new customers table and the old orders table, you'll notice that R tells me I must specify by when X and Y, which means the left and the right table, have no common variables. Remember, no variable names overlap between these two tables anymore, so I can no longer perform a natural join. Going back to my code. So what I have here is an example of how to use the by option to join these two tables when the relationship variable names don't match. I'm going to take my customers.new table, I pipe it to inner join. I'm going to join it with the orders table. I use the by option to tell R what the relationships are. And in my vector, I say cust.id, which is a variable in the left table, should be part of a relationship with the customer ID variable in the right table. I'll run that. And looking at the output, you can see that I get the join that I expected, combining the information in cust.id in the left table with customer ID in the right table. The output table uses the variable names from the left table. Given what you know of relational data and join operations in R, you should be able to start joining data between separate tables using these techniques.